Great. Um, you go. So yeah, this is the file that I have, and this is the architecture file.
Oh, so you don't have the structure plan, a very clean structure plan.
No, this is the latest that you sent.
Okay. Ingrid, could you send the structure file? Do you have that? Can you access that structure file to Hattie right now? But send without the seal.
Yeah, let me take a look here.
Yeah,
I
yeah. And
sent it.
meanwhile, Hattie, let's go over the proposal. So what's the middle wall you were talking about?
Remember that in the meeting that we had with the contractor, these parts, we tried to make changes and everything in the middle walls, right? So these are going to be the flush ones. The middle ones are the ones that we said we're going to change them to wood. This is where I want to make sure that termination point between the two scope of work is clearly defined. That's what I was trying to say.
Okay. Let me annotate. You're talking about sorry. Could you're talking about this one?
Yeah,
Okay.
for example, yes.
Okay. For this
Anything
one,
that is not in the perimeter of the
I
building.
see. I see. For this one, I don't think we're gonna make the above grade structure, the wood frame less, cause this one is typically technically exterior wall as well.
Yeah, yeah, that one. Yeah,
Yeah.
you're right. That one is exterior. The exterior ones are not my concern. The interior ones, that and it's not a concern. It's just matter of where we're gonna finish our job and it's gonna be picked up because we're gonna make changes. I want to make sure that those changes are picked up in your framing plan. That's
Okay.
all.
So I will annotate the exterior wall we have right now. So this is the exterior wall. These are all exterior wall. The only interior wall you are looking at right now is let me see. What's this? Why why we need a foundation wall here? This doesn't make sense. Okay, so this is our exterior wall. Okay, and this one, um, let me go another one using blue. This one is the wall, uh, next to the stair. That's
Mm.
the TGI company, the floor, they ask for a load-bearing wall for the stair. But I think that one, it's up to you guys how to design it. I think we might don't need this one, just need two sides. I'm not sure.
Okay.
So all of the green ones, they are exterior.
Okay.
Yeah.
That that blue one, that blue like rectangle that's going down, I think that is the exterior wall, and then there's a covered deck to the right of it on plan.
Which one?
That one at the back of the unit.
This one? Yes, yes. This is the exterior wall. And
Yeah.
also here.
Yeah.
Also here. They're both retaining wall and serve as the exterior wall. That's correct. The only question here is for this exterior wall, here we have a window.
We,
Here we have a
I think
window.
we gotta lag about 3 seconds when you draw something until we see it. So please make
Oh,
sure that when you draw it, wait a little bit until we see your cursor, and then
okay.
yeah.
Okay. I see. So, do you see the yellow here?
Yes,
Yeah.
we
Yeah.
Okay. So yellow here, we have like all of them, they are windows. So my question for Ellie is, do we need the same size of the footing here as the one here? Because here is the Sorry, I have to wait. Let me annotate.
I send you had in the email the floor
Correct.
plan. I have the
Oh.
the one I think if the permit, but I don't know if I'm allowed
Okay.
to send that one. But I send the other one to you right now.
Isaac,
So
keep it
yeah,
going, and I'll pull it up in a few seconds while you're talking.
Okay.
yeah. So Eddie, my question is, for the window, for the those window, and the you see the second green annotate. That's
Mm.
actually the wall. For those two different types of the configuration, do we need the same size of the footing? Or we can make the one below the window smaller because they didn't really pick up a lot of load here.
Yeah, I mean, it looks like so wherever you have the windows, we can make them smaller, but that load that's coming down it's gonna come down and it's gonna be distributed on either side of the window. So
Yes.
it's still the same amount of load, it's just distributed differently. So we can look into that and see how how we can make that more efficient. I'm looking at the architectural plans
Yes.
and where it says their trench tie beam 2x2. um I don't know if I have the latest one. This is from September
This cannot be 2 by 2. Yes.
9. The latest one I have right now is the SD on September 19. Is this the latest one?
This is the file that Ali is looking at. It's September 19th.
I think September 19 SD package. I don't think
Here,
this
look.
is the latest one.
Yeah, because if you go
Yeah.
to I'm on the oh, I'm sorry, I was on the second floor plan. I see it. I see what you're talking about.
Yeah, you see the first floor. Let's go to the first floor, Hattie. This is
Yeah.
second. Okay, let's go to the first floor. Yeah, here. So you can see. Let me clear my drawings.
Yeah. And the second floor just goes right over that.
Yes. So only here. Let me annotate, Hattie. Only only the one I annotated here. They're actually picking up the load. So
Right.
that's where I think we can make the footing, calculate the load, make the footing the right size. And the one below the window, I think we just meet the frozen code. Just to build. I kind of want to build as thin as we can, just to go down 42-inch till the frozen line.
Yeah, we like where it bumps up, where like inside that covered patio area, we could make that like you can do even like a 10 or 12 inch it's like
That will be great. Yes,
yeah,
that will be
because
great.
these aren't load bearing walls. These are just exterior walls because the framing is going left to right on screen, right?
Left and the
The
right.
framing for the second floor, the floor joists.
Let's say the floor joist. Hedy, do you have the floor joist? I remember our floor joist. I might be wrong. I remember our floor joist is like from top to bottom.
Okay. Let me
Yeah,
see.
I remember it's like this, but I might be wrong.
Okay.
Yeah.
If it were going that way, the foundation there should be a foundation going down the middle there.
You guys
I-
wanted me to get the framing here?
I
If
think
you
yeah,
it's
have
sent
the
to Hedy
latest
already.
handy, yeah, please send it over. I have
The
it
frame.
too, but
You have
if
the
you
framing, right, Hattie?
I do, but if you have the latest, can you please send it to me?
I think you have the latest, the framing. That's not update there.
Yeah,
Okay.
yeah.
If
The
you
one
have
the
a
one
hard time
Ingrid sent
finding,
you before. That's
I can send to you if you have a hard time finding.
yeah.
Uh, yeah, if you can send it, that'll be great. I'm looking for it too.
So,
Okay.
so for Ali, for the exterior wall, that is not a load-bearing wall. Can we just do the footing as a beam, just reach to 42-inch deep,
yeah,
meet the code?
absolutely.
Okay.
It's showing here that the footings for the exterior walls are like 36-inch wide. That's a really wide footing for just an exterior wall. I don't
Yes.
see why it needs to be that big at all. I
Yes.
think given the soils that you have, even the boring log you have, I mean, you could probably just do a 12 by 12, or not even 12 by 12, just like a 12 by like 10 if you want to even.
Just
Yes,
so
yes, that's what I'm thinking as well. Because if it's not this frozen line, for all of them, the depths I only want to reach to 2 feet.
Hmm. Yeah, absolutely.
yes,
I
me
don't even think
too,
we need
Hattie.
that. You talking about the width of the footings?
I'm talking about the depths
Uh,
of footing. For the waist, if the load bearing wall, what I think is usually if it's really you need that waist 3 feet and the depth 2 feet. I don't know. That's based on my experience here in New York. I'm not sure about the Ann Arbor, and I never did something like those wood structures, 3 stories. I only experienced with those high rise with steel frame.
Right.
This one I'm not sure, but I assume it should be less.
Yeah, it should be. I don't see why it needs to be 3 feet, but we'll run the calculations and see why they
Yeah.
designed it that way.
Yeah, and the soil, our assumption of the soil should be rock clay, 4,000 psi. So
Yeah,
which is good. Also, I see I saw Hattie, you excluded the drainage and the waterproofing at the rear wall, the retaining wall.
Good.
Yeah. Why, well, can I ask why you exclude that? Do you think we need that or anybody else can do that?
Um, I thought it normally goes to the architectural plans, and you and Ellie can correct me based on the experience, the drainage and everything, the details. Could be coordinated between the disciplines, but it goes on the under the architectural. Ellie, what
yeah.
do you think?
That's been my experience too. Like drainage or yeah, that goes in the same category as like flashing on the roof and stuff
Yeah.
like
Okay.
that. Waterproofing. Usually that's on the architectural side.
Okay. And how about the backfill instruction? That one, I mean, I didn't see anything like that in the structure set, but since you mentioned, that one usually done by who?
The backfill instructions.
Yeah, I saw.
Those are usually like in the notes for the structural.
Okay, okay, cool.
Yeah.
Yeah, yeah,
These files that Ingrid you just sent me. I'm gonna
Yeah, this is the
open the
calculations from the
yeah.
framing company, right?
yeah.
And
This
this
is
is
our
the
frame.
drawing. This is the drawings, the latest drawings that we have based
Oh, so
on, yeah.
they're going s- they're going free span all the way across then. Are they utilizing the middle wall? Hmm.
The way the architect's doing the middle wall here, this framing, he changed the direction. We can do both ways according to him, right? But he recommended us to change here just to not have any problem, like anyone forgetting about this important part inside. It's just like a reminder that they have to be pay attention over here. So that's why he changed the direction of the span over here. But yeah,
Okay. I want to make some annotate of this one, just to talk about our footing.
do
So
you think,
based on
Lee, sorry, do you think it's gonna change too much the framing right now based on
No,
the?
if they want to go with this, the framing will dictate the foundation, not the other way around. So whatever they decide, however they want to do the framing, we'll design the foundation accordingly to make sure
yeah,
it accommodates
Okay,
for it.
we do
yeah.
have
How do you,
one part. I'm sorry, Isaac. We do have one corner. I believe that was the let me see if I can annotate here. That was that was like a little piece that has to be designed by the engineering. Something right here, that has to be designed by the engineering. It's like a piece to connect the beams, something like that. Then we
Yeah. Oh, that's fine. We can
yeah,
do
it's
that.
just like a little piece that has to be, designed because the framing company doesn't have capacity to do that on their system.
Yeah, we can take a look at that. That's no problem.
Yeah.
Okay,
Um,
Isaac, you can go
yeah,
next.
yeah. So I will annotate. So for this one, we will say like oh sorry, this is too bad. Let me go. Mm, okay. Ali, do you think we only need these two as a load-bearing wall?
That's how it looks like it's drawn to me. I'll take a deeper look when I review this, but it looks like they're
Yeah.
using, yeah, look, they're using 14-inch eye joists to span about 20 feet, which is they can do those all day. So it looks like that's what they're designing it for, is those two being the two low bearing walls, and then the two walls that are parallel for the stairs, that are parallel to the outside, those two outside walls, those two as well. Yeah, exactly, right there. Um, it looks like they're utilizing those for bearing, and
Yes.
they're not using any interior walls um for bearing at all.
Yes. So
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 the
only
foundation, that makes
here.
the foundation plan like super over like over designed. I don't see what like where the loads are coming from to come
Yes.
up with this much concrete.
Yes, yes, I agree with you. That's why we that's why we need you. That's the one thing I repeatedly to bring up, but didn't get resolved. So there are a lot of walls they are not picking up the load, but we built a huge foundation beneath it. That doesn't make any sense.
Yeah, this
Okay.
is like a big this is like a big like boat of concrete.
Okay.
It's just crazy. Yeah.
Okay. So what do you think for the exterior wall, just for the zoning compliance? What's the thinnest what can we get the thinnest trench or
You,
the
you mean for the width of it?
yeah for the width? Because
Um,
the depth always has to be 42.
yeah, right. I have to check the calculations, but if the soil is looking the way it's looking right now, I mean, we could be like 2 feet, or it could be like a 24, like 28, 30, no more than 30 at all.
Okay. You mean the one not picking up the load?
No, no, the ones that are picking the load.
Okay. So the
Oh, you're talking about the ones not picking up the load?
yes.
Those, I mean, we can just do them like 10 or 12 inches thick.
Nice. Nice. That will be very good.
Yeah,
It's
yeah,
yeah.
100%.
Yeah, it saves us a lot of concrete. And okay, so for here, for oh sorry, this is so bad. I'm so bad at annotating. So for here, this side, this one, since we are not picking up the load, and I think we do have a I think we have a column here. This one, it's
Why
the
do they
same.
have why do they have columns there?
Can we go back to our architecture plan, Hattie?
Yeah,
Thank you.
yeah.
To the first floor. This is foundation.
You meant structural plan, these, right?
No, the first floor architecture, first floor plan. I think this is structure. Let's go to the architecture plan. That's the first one. Yes. Okay. Just
Oh, I get it. I see what you're saying.
yeah, zoom out a little bit. Yeah, here.
Yep.
Yeah, we have
Yeah,
a column here.
I see why.
Yeah,
Okay.
and also our foundation extend to here to this porch and here, right? Here we have like a special moment here because we are this whole lot is sloping. It's just what? Let me let me draw. It's
And
like this.
you got a tall retaining wall in the back.
Yeah, I
Yes,
saw I saw the section. I see which way the grade. I know the grade which way it's going.
yes. I'm talking about. 1 second. Let me annotate and let's discuss. I want to get a clear understanding here. So this will be our slab. Looks like that. So for here, so this slab edge is here, right? Basically, our slab is a little bit above our grade here. So for here, what do you think we should do for the slab edge?
So
Do
you're
we
saying
build a
this,
stem wall and spread footing here? Or we can make this just a second edge slab, just pour them one time, and we don't do any footing, just to make this like second 42-inch.
yeah, like a monolithic pour of
Yes,
slab
yes.
with the, yeah, we could do that. That's no
Okay.
problem at all. And then wherever the grade starts to drop dramatically, we can step the footing down with like a stem wall.
Yeah, this is what I imagined before, but I'm not sure if this is the most cost efficient way. If you think here, we can build a stem wall, just ask them to form them, build a stem wall and a spread footing. If that's efficient, we can go with that. This is up to you, Ali.
Yeah,
Yeah,
we'll run the numbers and make sure. We'll
yeah,
check and
yeah,
see.
yeah. Yeah, so you think here we can, but here we cannot do trench footing, right? We cannot.
Where was that again? I'm sorry.
This slab edge here.
Again, you got a 3-second delay.
The blue part, this polar part here, the blue.
Yeah, the blue part.
Yeah,
Yes.
right here, like that.
Yeah, the blue part we could do. So you think we can't do a trench footing there? Yeah, we'd have to do a stem wall because over there it's a lot lower.
Yes, yes, yes.
Yeah.
How tall is the drop for the grading? What's the height that we're talking about?
Looks like
It's
about 11 feet or 10 feet.
where you're talking about the rear or the front?
The rear with respect to the front, like what the
The blue
elevation
part,
difference.
the blue part, how tall is the drop?
From the front to the rear, the drop will be around 14 feet, I think. Yeah.
I'm talking about this elevation.
This one,
Between
this
the
is
grade and between the slab.
very little. I think here, I don't recall, but I think here is less than 1 feet.
Okay.
Yeah. It's not that much difference. It's just this moment here is a slab above the grade, and I don't know if we need a curb or something to go down into the soil, or we change the grading plan. We backfill here to make this soil level as our grade. I'm not sure, but this we can coordinate and discuss. If you think it's better to backfill here, we can coordinate that with civil.
Yeah, I'll see. Is there there's a topo survey for this?
We have a survey for this. Ingrid, could you send? Because I'm not using my usual like laptop. I don't have file right now.
Yes, I can send.
Yeah, thank you.
Yeah, no, it doesn't need to be now, but whenever just so whenever we do that, when we start designing, we would just need that information.
Yes. And also, Hattie, you can go to our section plan. I think at our section, we should already show this moment section. If not section, I would say actually the elevation here can show. Let's go to the section. Wait, we don't have a section here?
Yeah, this is all we have. I guess elevation describes it better.
Yeah. You can see
This is
here.
what
You
you're
can see
talking
here.
about.
Yes, you can see here. So you can see this is a slab. The slab is a little bit above.
Mm-hmm.
Yeah, that's the one I'm talking about.
Yeah, we can just form a little stem wall there.
Okay.
Yeah,
Okay.
I don't think
Yeah.
it should be a big deal. They can just form that out.
Okay. Yeah. Let me see if any other like proposal 42 dips footing.
I send the survey.
You did, thank you.
It's gonna be a beautiful building when it's done. This is really nice.
Yeah. Yeah.
Yeah.
Mm. Oh yeah, and for the CMU, they're not using the CMU. I saw you send the CMU, but our retaining wall, our GC, he want to use the ICF blocks,
Mm.
and the ICF blocks is 15 inch, and both form, like both sides, that's 2. So what's left in the middle is 11 inch. I will send those details if you need, like later, write to you. So when you design, you will know the size of it. And they want to build the ICF walls step by step, which means they're doing 3 times, just build like 3 feet and then backfill, and then build another 3 feet and then backfill to meet the 14 feet. I mean 4 feet every 4 feet to meet the 14 feet rear like a retaining wall.
Yeah.
And also, uh, since we are like a wood structure, based on the code, we need 6 inch footing or concrete above the grade. I'm not really understand that, Ellie. Do you understand that? Why we need that?
Oh, they want like a skirt around. Yeah, so that way, none of that way your what's it called? Your bottom plate isn't on grade. They want to just have it up, raised above the grade a little bit.
Yeah,
Um,
every exterior wall, they have to above grade 6 inch.
yeah,
Yeah.
yeah.
So what do you think is the best solution? I think I saw you said we can use CMU blocks. That's also our GC like talked about before. So using CMU block, oh, how we gonna do that? Because if we don't do that, we just dig the trench and pull the trench and the slab together, right?
Yeah. Well, I've been doing a lot of ICF lately. It's been booming recently. So I have good experience with ICF, but I've never used it for retaining wall purposes. I usually people will use it for their houses, exterior walls,
Yeah,
to get the insulation.
yeah.
But I've never heard many people use it for retaining wall purposes. So that could be interesting. I'll have to look into that.
Do you
We
think
did
other than
actually a
that?
job about 2 years ago that was for both purposes. I can also share those drawings when I find them with you
Okay.
if you would like to see that. Um,
You said you used them for retaining wall purposes?
yeah, I believe vaguely remember that it was like 3 years ago, a project 3 years ago, and uh, used it for both purposes. So retaining wall and structure purposes, and it was a pretty tall one. So we had to come up with more than usual rebars and thickness and everything for the ICF.
Right. Okay.
Okay.
I'm just not sure where the advantage would come in from using ICF with
Yeah,
instead of using the traditional block.
By traditional wall, you meaning
Like
the wood form?
no, like regular just masonry blocks that you get.
Oh, masonry. Okay, so just use CMU to stack them.
Yeah, I don't know why. I don't know what the different where the advantage would be with using either one.
One benefit is like you mentioned, the insulation, because part of our can you go back to our first floor? I believe it's first floor architecture drawing, Heidi.
yeah.
Um, this is the reason, at least I like the proposal of ICF. So when you go to the first floor, yes, you can see our retaining wall. Inside the retaining wall, we have a 2x6 uh star wall too. So which makes this exterior wall like very thick. But if we use ICF, we have the insulation. I believe the insulation value will go up to 26, which means we don't need to build the 2x6 structure inside the
Oh, I see.
Yeah,
I see.
building. Yeah,
It
to
makes
build
your
the
drywall thinner.
Okay,
yes, yes,
I see where you're talking. I was thinking this retaining wall was just for like the back patio or the porch. I didn't know. I didn't realize it was the other side of the retaining wall is going to be a living space. That makes
yes.
more sense.
Yes, yes. So that's why I like this idea. I think okay, we can do the ICF because
Yeah.
it will make our interior space larger and save us the work to frame another wall unnecessary just for
Yeah,
some reason.
absolutely. I'm very pro ICF. I like designing it, using it, and it's very efficient. And
Yeah.
I think it's a good product.
Okay, okay, yeah. Other than that, it's just the one thing I mentioned. So for all the wood structure, we need 6 inch above grade the concrete. So when we do the CMU of that, how do you think we can do? Because CMU don't have a 6 inch depth, do we? Do we have?
No, but the block, like 2 inches of it will be below grade, and then the rest of it will be above grade or something like
Oh,
that. So we can step the block to where we get at least that 6 inches minimum.
okay, but how do we create that small pit, like a 2 inch, like for every block, 2 inch, that create that pit for the for it? Cause I'm thinking pour the trench footing and the slab all together at once. And how do we place the blocks? I'm not really
Oh,
understand that.
I see what you're saying. I see what you're saying
Yeah.
with the monolithic pour.
Yes.
I mean, you could get. Let me see. Well, what if they just formed out? Can they even form that like a 6 inch bump up? They can't even really form that.
Yeah, that's a question. Cause if we if we dig the trench, it will be, it's a hole, and you
Yeah,
cannot place CMU on
yeah,
there.
right. I'll have to do some thinking on that one. I
Yes,
can. We'll figure something out though for sure.
yes. If in real construction we cannot do that, I prefer, like, I don't know, correct me if I'm wrong. I prefer to pour everything, like pour everything, just make some do it if we need some rebar to reach to the those 6 inch above, and we just frame that after the concrete is done, after the slab is done. Can we do that?
You saying put the rebar after the slab is done
No, no,
to
I mean,
stick up?
I'm saying let's pour the trench and the slab first, and then we form the 6 inch when the slab is done. Can we do that?
Oh, I see what you're
In
saying.
two pours.
Yeah,
Yeah,
two
two
pour.
Wants to
Oh,
pours.
send
yeah,
you two pours.
you could do that in two pours. Yeah,
Yeah.
yeah.
Otherwise,
They'll
I don't
form it
know.
out. Yeah, they'll just form it out after it's cured,
Yes,
and just pour it on the perimeter.
yes. And by mentioning the rebar, I'm meaning so we can make the rebar stick out. I don't know
Yeah.
if that area needs a rebar. If we need stick out maybe